Like if we're looking at this Ferris wheel, okay? Let's say this is divided into 4 parts. If we had this Ferris wheel and we put an x-axis and a y-axis, okay? If you had something sitting right here and it rotated down to here, okay? Let's just say it was a triangle, okay? What would happen to that shape? Would it change the shape? It wouldn't change, but it wouldn't necessarily be flipped like it was yesterday, right? It's going to rotate, okay? And the most important part of when you do a rotation, this is called the center of rotation. This, if I have an axis here and an axis here, the middle of that Ferris wheel, that's where that center is. Does that make sense? Okay, if that was not in the center of that, is it going to rotate effectively? No. Okay, so that center of rotation it is called about the center. That means if I said rotate about the center, that's what it means. It's in the middle, and I'm going to rotate something. Now, what directions can I go? What directions can this go?
Left and right way.
It can go clockwise or
Counterclockwise.
counterclockwise. Now, if I had a figure that was, remember, let's say this was in quadrants, say if you're in quadrant 1. If I rotated it 90 degrees, what does that mean? If I went 90 degrees, that's going to go where? Down here. But if I rotated 90 degrees counterclockwise, it's going to go where? The other way. What about 180 degrees? If I rotated it 180 degrees, it's not just flipping it, what's it going to do? It's going to go from where?
Halfway across.
Down to here. Okay, does that make sense? Okay, so it's a little bit tricky, but let's just go through some examples, and I think you'll understand. All right, some vocab that we're going to learn about. Write these down, please. Okay, center of rotation and rotation. Center of rotation and rotation. All right, so let's look at what that means. Okay, if, like I was explaining, on a Ferris wheel, a center of rotation is kind of like right in the middle. Okay, a rotation is a transformation in which a figure is rotated or turned about a fixed point. Okay, what you need to write down from that. Okay, a figure is rotated around a fixed point. Write that down. A figure is rotated around a fixed point. Okay, the center of rotation is that fixed point. Okay? The center of rotation is that fixed point. Okay, I'm going to pause this. So let's take a look. Let's say we have triangle LMN with vertices 5, 4, 5, 7, and 8, 7. Represents a desk in Jackson's bedroom. He wants to rotate the desk counterclockwise 180 degrees about vertex L. Okay, so if we're talking about doing this on a map or on the graph, okay, point L would be right here. Okay, and what did we say we're rotating at what? What was it? 180 degrees. Now, the thing about 180 degrees rotation, does it matter if we go clockwise or counterclockwise? It doesn't matter. Is it going to end up in the same point? Yeah. Okay. So let's take a look. What do you think a way we can figure out what the new coordinates are going to be here? Look at it. Where do you think the n is going to be? Well, first of all, if this is 180 degrees, okay, here's the L. Okay, how far up is the m from the L? 3. Where's that m going to be? 1, 2, 3. That m is going to be here, right? How far is that n from the m? 1, 2, 3. It's going to be to the left, right? So technically, when we finish, our shape should be like this, right? Okay, now, you can use a protractor. I don't think you need to do so. Okay, but that's rotated just like that. So we can tell that this is that same shape. Remember, L prime is going to be the same as what? L. Why? Because it's the what? Center of rotation, okay? I don't think you need to use a protractor because you can simply count how many the spaces are, right? Right? Okay. Okay, let's look at another one. And if I was going to write the coordinates, what are the coordinates of L prime? They're the same. What are the coordinates of M prime? 5, 5, 1, and what are the n prime? 2, 1. Okay, good. Okay, let's try another one here. Okay, so this one we're going to graph 90 degrees about vertex J. Okay, let's, oh, it wants us to do it on a separate sheet of graph paper. Okay, well, we're not going to do it on a graph paper.